You guys moved on to trig?
Yeah, we're back on trig.
Okay, that's what I thought. I have another student there, and that's what he told me yesterday. So this is going to be the last new material you learn for the year, I'm sure.
Yeah.
All right, and this is law of sines only, not law of cosines?
I think so, yeah. We're getting to that tomorrow.
Okay, all right. Well, let's talk about the law of sines. Whenever you have a non-right triangle, you use either the law of sines or the law of cosines to solve it. And what they always give you is 3 pieces of information. In other words, they give you a side, they give you another side, they give you an angle. Or maybe they'll give you 2 angles and 1 side. As in this problem here and this problem here. And in number 4, they give you 2 sides and an angle. Notice that every single situation, we have an angle and its opposite side. In other words, 42 degrees goes with 20, 58 degrees goes with 14, 17 degrees goes with R. Now notice in this one, we don't have the angle that's opposite 68. But we can figure it out, because they gave us 2 angles. We can always figure out the third.
Okay.
So the key to using the law of sines is knowing that you have to have at least 1 angle and its opposite side. And what the law of sines says is that the sine of one angle, the ratio of the sine of the angle to its opposite side, is the same in that triangle, no matter what. As long as you're within that triangle, these ratios are always the same. The sine of an angle over its opposite side is always the same. So, if we look at this first problem, what equation can I write? Geometry, trig, all of it always comes down to, can I write an equation? And incidentally, this works in reverse also. In other words, I can also say that A over sine of A equals B over sine of B equals C over sine of C. So it's not just with that combination. The reciprocals also are true. Do I have, in question number 1, do I have an angle and opposite side defined for me?
Yeah.
Okay, so the left side of the equation is going to be the sine of 42 degrees over 20. In other words, I've got one of those, meaning I can use the law of sines. What's that going to be equal to?
The sine of P over 17.
Solve that. You're going to need your calculator.
Yeah. So, do I just plug it in?
Pretty much. In other words, that's a number. That's a number, and that's a number. So I get sine of P equals 17 times the sine of 42 degrees, which is just a number, divided by 20. Come up with that number in your calculator. Make sure you're in degree mode, not radian mode.
Yeah. So, 42.
It's going to be a number less than 1.
Yeah, 0.568.
That's equal to the sine of P. Well, our first goal here is not to solve for the sine of P, but it's to solve for P. In other words, if I can figure out that angle, well, then I automatically can figure out this angle. And once I figure out this angle down here, I can figure out this side. The trick is to solve for all three sides and all three angles. So what is P? If the sine of P equals 0.568, what is P equal to?
Is it the inverse? I mean, the inverse sine of
inverse sine of 0.568. What is that?
34.6.
34.6?
Yep.
And that's in degrees.
Yeah.
In other words, we always take the trig function of angles, and we always take the inverse trig functions of ratios to get an angle. So in this step right here, we're solving for the angle. We know that the sine of that angle is 0.568, so by taking the inverse sine of 0.568, we get the angle. Okay, now that tells me that this angle right there is excuse me, 34.6 degrees. So if that is 34.6 degrees, what is this? In other words, that's the next step, is to try to finish drawing the triangle. I've got this at 42.
It's about 104.
How much?
About 104.
All right, I don't mind rounding off. I think they should always be rounding off here. I don't think they should be using decimal. It just makes it more confusing. Okay, and now that's 17. That's 20. I've solved for how many sides of this triangle?
2/3 of them.
Well, 5/6 of it. I've got all three angles and I got two sides. I only need one more thing. This side right there.
Okay.
So how can I solve for x? Well, I noticed now that I'm looking at it that they only ask you to solve for P. Okay? And we did.
Yeah.
But a typical problem will ask you to solve the triangle. Interesting. Have you talked about the ambiguous case of the law of sines?
No.
Okay. How would I solve for x here?
You could take one of the sides we already know and do the law of sine again.
Give me an equation.
Sine of 42 over 20 is equal to the sine of 104 over x.
Now, notice that if I do that, I can solve for x, but I got to cross multiply and divide, right?
Yeah.
So wouldn't it be better if I had x in the numerator? In other words, what if I lay it out like this, which I'm allowed to do? Notice the difference. Now I only have one step. I can multiply both sides by sine of 104 degrees. So I don't have to cross multiply. You don't always cross multiply just because you can. In other words, my variable is in the numerator already. So if I multiply by the sine of 104, it gets rid of this denominator and solves for x in one step. So it's a minor thing. And, you know, you're never going to get in trouble if you do it that way accidentally. As long as you can solve for x, you're fine. But once you get more familiar with these, if you can put your variable in the numerator, it shortens the problem by one step. And,
All right.
and notice that that's just a number. In other words, everything there is a number. Sine of 104 is a number, times 20, divided by sine of 42, which is a number. So as long as I have a calculator, I can come up with x. And x better be the largest side in this triangle. There is a rule for triangles that the largest side has to be opposite the largest angle, and the shortest side, 17, has to be opposite the shortest angle. So let's say we went through this math and we came up with x equals 19, we would know that we've made a big mistake. There's no way x can be less than 20. Now, I don't know what x has to be. It probably is going to be in the neighborhood of 30 to 40, but we don't really need to know that. We just need to know that it's going to be the longest side of this triangle. If you're not getting that, you've made a mistake. All right. Let's look at number 2. Again, they're not asking us to solve the triangle. Let's just solve for q using the law of sines. Should I put q in the numerator or the denominator?
Denominator.
No, remember it's going to be the only variable. So let's leave it in the numerator. Q over what?
Sine of 51.
Equals?
14 over the sine of 58.
You see why that's better? Because now I can solve for q by doing one step only, and that's multiplying by the sine of 51. It gets rid of the denominator and gives me q directly. Whereas if q was in the denominator, I would have to cross multiply and then divide. I would have to do an extra step. So when you're using the law of sines and you have a variable, just kind of think about starting out by putting it in the numerator, not the denominator.
Okay.
About number 3. Give me the equation.
R over the sine of 17 is equal to, this one's not easy. Is there any, I think we have to work with two variables in this one, right?
When you have two angles, always figure out the third angle. What's that angle right there?
Oh, okay, I get it now. 1 second. 180. 115.
Okay, so what's the right side of this equation?
68 over the sine of 115.
You got it. And again, that's a number. That's a number. So all I got to do is multiply both sides by sine of 17. And I will solve for r in one step. How about number 4? Our variable is the angle. So let's put that in the numerator. Let me take that back. Let's not start out with our variable. First of all, if the law of sines applies here, then we have to have an opposite side and an opposite angle. Do we have that?
Yeah.
Yeah, we do. We got 16 and we got 66. So let's not worry about whether our variable is going to end up in the denominator or the numerator, yes. Let's just start our relationship. Yeah, let's do it. In other words, we're not going to get ahead of ourselves. We'll start there. An opposite side over the sine of its opposite angle has to be what?
Um,
Now let me draw this picture. This a little bit different. That's 66. That's 16. That's 15. That's S. Let's call that X. I had to call it something because they give us an unknown angle and they don't give us this side. So,
oh, can you just find the side?
can I solve for X?
Yeah.
Okay, what's the rest of this equation?
X over the sine of 15.
No, remember we always take trig functions of angles. We take,
Oh, the sine of X over 15.
and we got to have it in the same, we can't switch it around.
Oh, yeah.
So we need sine X in the bottom. And we need 15 in the top.
Okay.
Okay. In other words, because I didn't think far enough ahead, I didn't know how to write the left side, but it's not that important to have the variable in the numerator. As long as you get it right, that's what's important. Okay. Now, once we can solve for X, we're going to be able to solve for S easily, correct?
Yeah.
Once you know two angles of a triangle, you can solve for the third angle really easily. You just add these two up and subtract from 180, and that's going to give us S. So solving for X is the first most important thing. How do I solve that for X?
You could divide both sides out first.
Let's think of cross multiplying. Whenever you have a fraction equals a fraction, that's what you typically need to cross multiply. Cross multiply is really just doing two steps in one. In other words, maybe I'd multiply both sides by sine of 66, and then I'd multiply both sides by sine of X. Well, what that gives you is this. In other words, all I did was cross multiply. Okay?
Yeah.
Now you have sine of X equals 15 over 16 times sine of 66. Go ahead and come up with a number for that.
You get 0.856, and then you find the inverse of that.
Correct. To solve for angle X, you need the inverse of that number.
Yeah, that's 58.9. So 59.
How much? 58?
59.
59? Okay. Now, if I fill that in for 59 degrees, I could use the law of sines to solve for S, but that would be the hard way. The easiest way to solve for S is to add these two angles together and subtract from 180. Looks to me like that gives you 55. S has to be 55 degrees. So this was the hardest problem of the bunch, only because we had to introduce a variable for this angle that we called X, and we had to solve for it. And we had to do all of that before we could solve for S. You don't ever have to use the law of sines to solve a right triangle. You can. I could say the sine of t over 22 is equal to the sine of this angle over 30. Well, I don't know this angle, I don't know that angle, so that's not going to help much. However, what can I use to solve number 5? When you're dealing with a right triangle, just think trig functions. That's all you need. What is the tan of t equal to? In other words, I do not need the law of sines. In fact, I never want to use the law of sines to solve a right triangle. Tangent is what? Opposite over adjacent.
Okay, that's 22 divided by 30.
Now it's a piece of cake. T is equal to the inverse tan of 22 over 30. And that solves for that angle. Do not need the law of sines. Never need the law of sines or cosines when you're dealing with a right triangle. Okay. Mark, I hate to run, but I have a 5 o'clock.
All right. Thanks, David.
Okay, I'll talk to you on Thursday.